Hi. Okay, so I'm starting off the Google Hangouts on air for Kubernetes Helm, and there are 0 viewers right now. Okay. Um, anyway, yeah, so maybe people will come in midway, but I just wanted to start doing these sessions as a way for me to, I guess, practice public speaking and also try out just like sharing technologies that I'm coming across and any insights that I might have into them. So for this one, I'm going to be covering Kubernetes Helm. I'm going to start sharing my screen. So let's kick that off now. Ooh, there we go. My screen is visible. Great. So, what is Helm? Let's head over to. Well, this is the docs page for Helm, but it should do. But let's head over to the Helm page itself. Great. So I'd just like to say a little bit about some assumptions that I have with this session, right? So I'm making the assumption that whoever's coming in has some idea of what Kubernetes is. I mean, you don't necessarily have to be a Kubernetes expert, but if you just have some idea about Kubernetes, that's a good start. But if you don't, I guess here's the quick pitch for Kubernetes. It's an orchestrator. It allows you to orchestrate your container workloads by automating deployment, scaling, and management of your containers. And what that means is you can essentially declare, or in a declarative way, you can specify the ins and outs of your applications and not worry about, I guess, what machines they run on, because they're containerized and the orchestrator will schedule them in whatever, I guess, whatever compute is available. So that's the long and the short of Kubernetes. Comes with a whole bunch of bells and whistles, but when it comes to actually managing your, I guess, versions of your applications within Kubernetes, before Helm, I don't think there was really a way. You kind of had to manually handle that whole thing. So it would mean, I don't know, bringing down a deployment, and then kind of like bringing up another one on the side or something to that effect. Right. So Helm came along, and Helm is essentially a package manager. And I think I'm going into too much detail about trying to explain what Helm is or isn't, whereas this is really just meant to be an introduction to making use of Helm. So I think the best way to show that is by me doing stuff. Cool. So I'm working on a Mac OS X, and I will just go through the steps of getting Helm and getting started with using it. So let's head over to the quick start guide for Helm. So the requirements for Helm is you need a Kubernetes cluster. I guess you have to make a decision about the security configurations to apply the installation. And then you need to go ahead and install and configure Helm and Tiller. And this is something that we can take a step back and just think about, or that I can explain in a little bit of detail. So Helm works in a, I guess, client server type architecture. Tiller is actually the server part of Helm. So you can see that it's described here. So Tiller is basically the part of Helm that kind of runs within Kubernetes, right? So it's an in-cluster server that interacts with the Helm client, and it also interfaces with the Kubernetes API server. So what you do, or like the typical workflow is, let's suppose you have Helm installed, which I'm going to go through, and you have Tiller installed, and I can show you that by just heading over to Kubernetes, and I have Tiller installed in the kube system namespace and you can see that Tilla is deployed over here. So the typical workflow is you use Helm in order for you to install charts, for example. And these will be essentially posted to the Tilla server, and then the Tilla server will actually kind of like operate on your templates, and then bring them to life within Kubernetes. And I'm going to show that a little bit later. I'm going to pause for a second and just, I guess, try to see if there is anyone joining us. I don't know, maybe. We'll see later. Anyway, let's proceed. So I'm gonna go ahead and completely nuke my minikube instance, which I don't know if that's such a good idea. So I can show you from scratch how I go about installing Helm and getting up and running with Helm. Cool. So let's see. So if we head over to the docs again, one of the things that you need is to essentially have the kube control CLI available. That allows you to speak to your Kubernetes cluster, right? So as it stands right now, because I killed my my minikube instance, the kube control CLI has nothing to speak to, so it's just going to hang for a bit until it times out. And I'm going to get rid of Helm, so that you can see me start from scratch. And I'm just trying to remember what the title of Helm is, so you can see that I'm going to brew uninstall Helm, and now if I type Helm, I got nothing. Great. So let's start completely from scratch. How do you install Helm? So it's as simple as using brew. So you type brew install Kubernetes Helm, and brew will just do its thing and it will install Helm. And Helm is essentially a command line interface. You access it by typing Helm, and you're good to go. So there's a bunch of I guess commands that are available via Helm, and I'll go through those in a moment. But while I wait for that, let me present to everyone and minimize this. Cool. So Helm is now installed. So if I type Helm, we can see, I guess, the help or the description of what Helm has to offer. And Helm has a lot of functionality, which is kind of centered around this idea of charts. And charts essentially kind of like encapsulate the idea of a deployment. So that can include deploying pods, stateful sets, services, ingresses. It's basically like a bundle of Kubernetes resources that are useful within the context of like deploying something. Great. So you can dive into that a bit later, but I'm going to go through some of them as we go. So I'm going to type Helm status, and I don't think that will work actually. Sorry, it's Helm version. So I typed Helm version, and right now we can see the client version, but we can't see the server version because there is no server. So it's just going to hang because actually there's some configuration in my system that makes it so that Helm is trying to get the version from the Kubernetes cluster that no longer exists. I'm going to go ahead and run minikube start. And minikube start essentially allows me to kick off a local Kubernetes cluster. So I'm starting the VM right now. And it will take a moment for this to run through, but this is like minikube is great from the standpoint that I don't have to provision resources on some cloud platform in order for me to play around with Kubernetes. I can kind of get like, I guess most of the bells and whistles of Kubernetes locally within a VM. So minikube is good for that. And that's the environment that we're going to be using for this session. Cool. So while that loads, I'm gonna go ahead and play around with Helm a little bit. So I think one of the things I can do is use Helm template, which allows you. Let's find out what Helm template can do. So Helm is powerful in one regard because it allows you to template and essentially kind of like abstract certain bits of your manifest, your Kubernetes manifest files. And I'm going to go ahead and show that, but I think my minikube is actually done or nearly done. So it's starting the cluster components. Should be done in a moment. But let me go ahead and just play around with this a little bit. So this is how it would work. And I'm going to go ahead to my IDE. Here's a chart that I prepared already. And for demonstration purposes, I would like to, let's see what I can do. So I'm going to create a new Scratch file with this in there. It's called demo.yaml. And I'm going to create a file called demo.yaml. And I'm just going to show you how this works. So we have a YAML file called demo.yaml, and it has this kind of like substitution thing, which you might be like, what is this? And this is basically Go templates. So I would recommend going and searching for Go templates in order to kind of understand how those work. But essentially what's happening here is some values are being provided at runtime, and then those are being substituted into this file. And Helm has a templating system that allows you to basically use templates in order to generate your manifest. So that's already a huge benefit beyond the rest of what Helm offers. So let's see what that looks like. So this file is called demo, and if I run Helm template, I'm just gonna show you this section here, which says that this does not require Tiller. So this does not require the server-side component of Helm. And you can see that it will fake some stuff, blah, 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 blah. But essentially what this will do is you can give it some values, and then it can essentially generate a file from the template. And this is basically what Helm is doing when it's actually using Tiller. So let's try this out. So the chart that we're going for is called pet store. I'm going to come across this chart later, so that's why I thought it would be cool to use it now. Let's check this out. Cool. So let's well, we don't need to change directory because it's the same directory. You can see that I have some folders within the playground. Folder pet store is a chart, and what I'm going to do is specifically just get the output for this. So if I run this, you'll see that it says kind is equal to 1. And that's because it's actually using values from this file over here. You can see that the replica count is currently equal to 1. And we can change that in line. And this is very much the same way that it I guess, works when you're using Helm in its natural state. So let's say replica count equals deployment. So set is a way for you to kind of like inline specify values. So if I use Helm template again, you can see that I've just generated a YAML file whose source was the demo.yaml file that I mentioned previously. And the substitution took place, which is pretty cool. So if you've been wondering how you can essentially get templating for your Kubernetes manifest, you can actually just use Helm for that. It's already great for just doing that bit. Cool. So let's go back to minikube. So minikube is all set up. If I run minikube status, we'll see that it's running. I have a running cluster and all's well. So if I run kube control get pod now, we actually get no resources found as opposed to the command hanging. And we have a bunch of namespaces that are made up already. So at this point, we have a blank Kubernetes cluster. So let's get to work. So once again, if I head over to Helm and I run Helm version, you can see that it says error, could not find tiller, because now it can actually communicate with the Kubernetes cluster that kube control is set up to speak to. So let's do the first thing that is suggested after you have installed Helm. You have to initialize tiller. So this is the Helm documentation. Yeah, cool. So let's go back to the section where we have to install tiller. So if you run Helm init, this is a really cool command. What it will do is it will actually install tiller for you. So it's going to install tiller in a specific namespace. So it's in the kube system namespace. So what I can do here is I know that it's going to install it as a deployment. So I can basically watch for deployments in that namespace. Like right now, there's nothing. So let's go ahead and do this. So Helm init, and it should now have installed tiller. So you can see that this changed, and it is now deploying tiller. And that's kind of done already. And if we head over to the pods in that namespace, you'll see that. Oops, my mistake. Right. Okay. Yeah, that's better. So you can see that there's a new pod that's been installed, and it is tiller. And I'm gonna go ahead and clear this, and go back to the Helm CLI, and I just want to focus on this message here. So tiller actually has a privileged position within the Kubernetes cluster. It's able to deploy, I guess, like arbitrary workloads. And if you're running Helm and tiller in production, then ideally you want to have some kind of policy in place to make it so that you can secure Helm, and also you can make sure that, I guess, tiller is able to do only what you want it to be able to do. But that's a subject for another time. For now, let's go ahead and run Helm version, and we can see that we now have a server version, which is the same as the client version, because it was the client that actually installed the server. You can install the server independently, but in this case, I installed them at the same time, which is cool. Great. So now we have tiller running. It means that we essentially have all the benefits of Helm already set up. We didn't need to do any fancy configuration because we're not running in production, and it isn't really the time for us to go into details about how to configure Helm. Great. So I'm going to clear and proceed with the tutorial for installing Helm. So one of the first things that when you're installing Helm, they ask you to kind of try is install a chart. That bundle of like the bundle that represents a particular application. It's like it's a package for a particular application or several applications, or service. So in this example, they're showing us how to install MySQL. but I'm going to go ahead and try out PostgreSQL. So the first thing that I'm going to do is Helm search. And what that does is it shows me all the different charts that are available within like the Helm stable repository. And you can see some cool and familiar things like a Docker registry, I guess, I don't know, memcached, MariaDB, etc., and even TensorFlow for your machine learning needs. So let's find out if Postgres is in there, and Postgres, of course, is in there. So what I'm going to do is run Helm install stable PostgreSQL. And when you install a chart in Helm, essentially what happens is Helm gets the files that represent the chart. And what that is something like this. So this is a typical chart. There's metadata describing the chart. There's a default values file. And there's a bunch of templates. And once those templates are kind of like evaluated, I'm going to go ahead and delete this from earlier. Once the templates have been evaluated, they're actually kind of like posted to Kubernetes. So once this deployment manifest is evaluated and something like a YAML file is generated from this template, then you actually have a deployment created within Kubernetes. And then at the very end, you might get some notes output. And once again, this is just a Go template. And you'll see what this looks like for PostgreSQL. So if I go ahead and run this, and in this terminal here, I'm just going to go ahead and watch for pods as they come along. So right now there are no pods, and if I run keep control get pod, you see that there are no resources found. But with the watch flag, we'll wait, and then as pods come, the screen will change. So what this will do is it's going to use a lot of like default parameters or values. So it's just installed the PostgreSQL chart. What we have here is a whole bunch of like Kubernetes resources. So a secret was created, a config map, a persistent volume claim, which makes sense because a Postgres database is stateful, a service to kind of like expose like, I guess, the underlying deployment. And you've got like the deployment here, and then you've got the pod that is generated as a result of the deployment. And then this is the equivalent, like this is the notes section, which basically tells you how to get up and running with the chart once it's been installed. So what happens when you actually install a chart is you get kind of like an installation. I know that sounds like I'm repeating myself, but installing a chart, like every time that you install a chart, a different installation is created. And I'm just going to kind of like show that in a moment. So before I do that, you can see that a pod has been created. It went from pending, container creating, to actually running. And this is a pod with Postgres in it. So now I can go ahead and run kube control get deployment, for example. And you see that there's this peakant moth PostgreSQL. And peakant moth is like the installation identifier. And what that means is within Helm, like Helm actually stores a list of all the installations that it is currently managing. And I can show you what that looks like. So if I type Helm list, you'll see that there is an installation called peakant moth. It is currently in revision 1. When was it updated? It's currently deployed, and what chart was used in order to deploy it, and what version of that chart. and in what namespace was it deployed. So that's the first step. And just to demonstrate the fact that every time that you install a Helm chart, you get a different installation. I'm going to go ahead and disregard all this stuff. Like we're gonna install and actually play with the next installation. So let's disregard this stuff. So let's clear and let's install again. Oh, so we get the very same thing. A new container is being created. So I'm gonna go ahead and run kubectl get pod, and you see that we now have two containers. There's the peacock moth that we had earlier, and then now we have bold lionfish. Where did that come from? Well, that came from the second installation. So you can see that we have two installations of the PostgreSQL chart, and these can be managed independently. So that means as I make modifications to one of the installations, the other one stays as it is, and I can roll back, upgrade, etc., each one of these installations independently. And hopefully I can show that with my demo application in a moment. Cool. So let's clear that and actually interact with the PostgreSQL chart. So the first step within the notes of like the PostgreSQL chart is we need to get the password for the Postgres user. And as far as I know, and in fact, I don't even need to guess. What I can do is I can do Helm list shows me the installations, and then I can Helm get, and that will show me all the different manifests that were generated for a particular installation. So you can see that. Let's go ahead and clear, and then run that get. Okay, maybe not. So okay, yeah, that works. So I cleared it, and then I ran Helm get bold lionfish. So I'm getting this particular installation, and we can see that the chart that was used, the same metadata that was available when we ran Helm list. But then at the bottom, we can see what values were supplied by the user, because of course you can specify values for the chart at runtime, and computed values. And computed values are essentially like a merger of user supplied values and default values. And then these are used within the manifests. So for the Postgres SQL chart, here are the manifests that are actually generated. And you can see from these initial comments which file or which template was responsible for actually generating this manifest. So a secret is created, and this secret has the Postgres password. And then a config map is created, which it's not clear what the config map has in terms of information. Actually, no. Yeah, I'm not sure. And then there's a persistent volume claim, and I showed that already. But the part that we really want to have a look at is the deployment. So we can see that the deployment is actually just using a Postgres 9.6.2 image. And if you head over to Docker Hub and you look this up, you kind of like get. Yep. So there's some information here about actually setting this up. So for example, you can specify the password for the user that will be generated by the container when it starts. And you can see that what's happening here is we're using the Kubernetes secret key reference in order to actually specify the value of this environment variable, right? Among other environment variables. So I just wanted to show that quickly. Let's go ahead and clear this again. So if we try to get that secret, oh well, the Postgres password. Let's get the value for that. So this is the value, and you can see what's happening is we grab the secret, and then we get the specific, like, we use the specific JSON path to get the value of the password, which is a base 64 encoded string. And then we decode that, and then we echo to just add like a new line. So this is the value of the password. And let's go back over here. So we actually want to set this to an environment variable. So let's go ahead and do that. Also echo PG password. Yep, that's it. And then if we run this, then this should allow us to connect to the database, because we're just going to run a really simple container which never restarts and has a interactive terminal. It sets the environment variable of PG password to PG password. And then it uses PSQL, which is like a tiny little client, to actually access the service bold lionfish Postgres SQL, because as part of the chart, we actually created a service, and I can show you that. So get service, and you can see that there is a service called bold lionfish Postgres SQL. And if you've played around with services in Kubernetes, you know that if you're in the same namespace as a service, then you can access it through the host name that is its name. It's just kind of part of like Kubernetes networking, I guess. So I'm going to go ahead and paste. Well, let's close out. Let's clear this. I'm going to go ahead and paste this command. And remember, the PG password is already set. And what should happen in this moment is we should be able to go into the bold lionfish Postgres SQL database. So let's hope for the best. Or while that loads, I think it's probably a good idea for me to just see what's happening. Okay, cool. So the container is creating. In all likelihood, what's happening is, oh yeah, there we go, it's done. It was just pulling. So if I run kubectl describe, or it's called a describe pod, you can see that what happens is the pod was scheduled. Some volume mounts were loaded, whatever, and then the image was pulled, and I think that's what took a little bit of time. So that's why there was a lag. But then the container ended up being created and then started, and we can see all that over here. So I'm actually in the Postgres, like I'm actually in bold lionfish Postgres SQL, like that instance, right? And I'm accessing it through the psql command line interface as the Postgres user. I can run, I guess, DT in order to find if there are any tables. And because it's a new database, there's nothing in there. I can run DU to try and find out if there are any users. And of course, there are users. And well, there's only one user. It's Postgres. And I can actually start running SQL in here. So, for example, if I wanted to create a table, let's so that I don't butcher SQL, let's do create SQL. Let's just grab a random statement for creating a table. So I'm going to go ahead and run this, and you can see that I've created a table. And if I run DT again, I'll see that now I have a table called persons, and I can actually start filling that up. And the cool thing is, I was able to actually get this running using completely just using Helm, which is cool. So I'm gonna go ahead and Helm list and get rid of those two installations. So bold lionfish, get rid of that. and weekend moth. So if you're used to managing Kubernetes resources by actually like generating manifest and then running, I don't know, kube control apply or kube control create, I feel like you would have an appreciation for how simple Helm makes things. So right now I would have had to like delete a whole bunch of things, but right now, if I run kube control get pod, all the stuff that I was working with, gone. Deployments, gone. Like all of that has been cleared up with one simple command, which is just like Helm delete. And I think that's incredible. So let's go around and show what it looks like for you to create a chart. And I'm going to try and be fast about that because I told myself that I'd only do this for like 1 hour. So let's see. So I use this guide over here to just create your first Helm chart. So Helm actually has this command called Helm create chart. Oh, well, Helm create, and it allows you to create a really basic chart. And as I mentioned earlier, a chart is really just made up of a chart.yaml file, which is metadata for the chart itself, a values.yaml file, which I guess provides like defaults for your values. And then it has templates. And templates basically make use of values.yaml and also values from chart.yaml in order for them to, I guess, dynamically generate your manifests. And that's about it. We can go into greater detail, but for now, I think that's enough. One thing that I'd like to touch upon is this idea of like a dry run. So you can actually have a look at what your chart looks like when it is generated without actually deploying resources into Kubernetes. And I'll just show what that looks like right now. So if I head over to my IDE over here, I have my chart, which is in pets, which is in this folder here called pet store. And if I list the contents of this folder, you can see that pet store is here. So if I run Helm, well, I run Helm install dry run debug for the chart pet store, you're going to see all this stuff generated here, right? And all this stuff is essentially a dry run representation of what my manifest will look like using the values that I have provided or the computed values. And actually, if we dive into this values.yaml file, let's try and find where we've got our host. So you can see that in the values.yaml file, there's like under ingress, there's ingress host pet store frontend.local. And this is used to calculate or to generate the value here at the very bottom in the ingress. And what I can do is I can do another dry run where I use the set command, which allows me to modify this value. So that's ingress dot host, the first entry, and I'm going to change that to I don't know, meow.local or something. And if I clear this and then I run that, you'll see that. Let's have a look. So ingress host meow.local. Sorry, it's not host, it is hostess, plural. And then now you can see that that's been changed, right? So you can actually, like, dry run is quite useful from the standpoint of being able to kind of sanity check the manifest that you're going to generate. And I guess you can kind of use that for testing as well. Cool. So let's actually look at the contents of my my deployment. So, sorry, not my deployment, my chart. So I've basically used the default pet store chart. There's a deployment, template, there's an ingress and there's a service. And I just have to make sure that my ingress is working perfectly fine. So what I've gone ahead and done is have an entry in etc host for pet store front end.local, so that can be resolved to the IP address of minikube, and I just want to make sure that that is working. Cool. So that's working. I'm not going to go into detail about what ingresses are. That's a topic for another time. But I need an ingress for my chart to work as it should. Cool. So I'm not going to dive into every single one of the template files, but the ingress is used in order to, I guess, direct traffic into my Kubernetes cluster. And the service is basically, I guess, a way of like load balancing traffic between like several pods. That's probably not the most robust description of what a service is, but that's what you get for now. And you can see that I've provided like values. It expects, like this chart expects values, right? So for example, here we're using values.service.type, and if we go to the values file, you can see that service.type is actually cluster IP. It's going to be running on port 80, which is to say that yeah, port 80 will get substituted here. And yeah, this is basically just the values being substituted. Let's head over to the chart, to the deployment, sorry. The deployment is really the important part. So I've gone ahead and created a really simple create React app application. And yeah, like I literally just use the CLI, like the create React app CLI. If you don't know what create React app is, I'd say head over to create React app. Oh, I think that's it. Well, you can get it and by Facebook, and it allows you. It's like it allows you to create React apps with no build configuration. So it's pretty convenient. And I think this is an example of what happens. So you run create React app, whatever the name of the app is, and then it will do all its magical stuff, and you basically have like some scaffolding for your React application. And what that will look like is something along these lines, right? So you have a package.json, a public folder, and your source files, and that's great. So that you don't have to go through a long and arduous journey setting all that stuff up. So I've run that already, and I have a really basic application here. And all it does is it says welcome to React in Docker version something. Let me just, I'm going to go ahead and run it in development mode so you can see what I'm talking about. I feel like looking at stuff helps. So I have a Docker Compose file that allows me to use the development Docker file to basically just run the application in development so you can have a look. And then I have a production Docker file, which allows me to run the application in production. And I use Nginx. So basically, I build all the static files for the React application. And then this is like a multi-stage build Docker file. And then I pass on the static assets into a container that is running Nginx. And then I use Nginx to actually serve the contents of like the production build. But for now, we're going to use the development build to just show locally with Docker Compose, not Kubernetes, what this application looks like. Cool. So I'm going to run Docker Compose up, and that's going to arrest my terminal. And you can see that it's running React scripts up, it will start, and it's starting the development server. And if I head over to localhost 3000, you can see there's welcome to React in Docker, blah, 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 which is great. And because it has all the cool, fancy, like it's watching your files when I make a change and I save, you can see that that's immediately reloaded. Cool. So let's use this as like our example for Helm, right? So let me close this down and kill that. So what we want is we want to package up this application in a container and have it be deployed using Helm. And then essentially explore the features of Helm, like rolling back, upgrading, etc., all the versioning that Helm provides us. So at the moment, we got nothing in Helm. And since I'm in minikube, I got to use the Docker that is in minikube. Otherwise, these containers don't exist. Cool. So let's try this out. So Docker images. So there's some images in here, but we don't have the image that we need, which we can see from the deployment that the deployment is expecting the values to have an image repository and an image tag. What are those values? Well, let's see. So we're looking for pet store front end, and we're currently looking for a tag called latest if we're using the defaults. Cool. So let's go ahead and build our front end and name it accordingly. So I have a script ready, which basically runs Docker build with the production Docker file. You can see that here. And then it will tag it accordingly. So what I'm going to do is run build. And it's gonna take a moment, but it should be done. But while that runs, let's go ahead and just look at the Docker file a little bit. So this Docker file, as I mentioned earlier, takes the static files and essentially packages them up in an Nginx container. And then it takes, well, yeah, that's what it's doing right there. And then it exposes port 80 because I guess Nginx operates on port 80 if it's just HTTP traffic. And then we're packaging all that up in this deployment, right? So let's have a look at the container. So we have a container here that is using container port 80 as expected. We have a liveness and a readiness probe to just make sure that it's healthy. And then we can check out our service now. So the service is just like a typical service. It will use the service port, which of course is port 80. And it's going to use the appropriate selector so that it catches pods that are created by this deployment. Where things get a little bit interesting is in this ingress. So the ingress is actually how the outside world gets access to our application. And we're just ranging or looping through hosts that are provided in the values. And if I go ahead and do a dry run again, but this time without changing anything, so it's pet store. I'd just like to highlight something. In fact, you know what? I'm going to output this to demo.yaml. Cool. So that should come up now. And you can see now that what you get is this ingress here. And this ingress makes it so that if traffic comes in to the ingress controller with a host of pet store frontend.local, and on the root path, it will get pushed over to the service, which is called, I guess, like whatever service was associated with this particular deployment. And you can find that the service is up here, and the deployment that the service is actually pointing to is down here, which is pet store, front end, latest, etc., etc. Cool. So how are we doing for build? All right, there's a little bit of time to go. So while we're still here, I'd like to just mention that, like, if you run set, and let me just close some of these aren't necessary. If you set inline the value of the tag, then we can essentially have a deployment manifest that's deploying a different version of the pet store front end. So what that would look like is if I ran image.tag, and let's have a look at the demo.yaml to find out where this is happening actually. So image. So instead of like showing everything, let's just use grep. This set in the first instance. So if you run this, you can see that you get image, pet store, front end, latest. But if we use the inline set, then what we can do is say, what was the value again? Image.tag equals version 1, let's suppose. And then now you can see that the manifest generated from the template is v1. And I'm going to use this in a moment in order for us to experience Helm's other features, right? So now we have the pet store front end image built, and it's available in here. Yep, it's here. It was made 36 seconds ago. Great. So this is the latest. So the first step that we're going to do is I'm going to go ahead and stop running these dry runs and actually run helm install pet store. I'm going to clear that and run. Cool. So that should be running. And you can see that we've created a pod service deployment ingress as expected, right? Because that's all that we have. We have an ingress, a service, a deployment, and the deployment will create the pods. And apparently this deployment or this installation of the Helm chart is called Falling Penguin. And you can see that in my notes section, I'm outputting over here, if we have an ingress, the value of the paths, and this is one of the paths. So let's try and access that. Cool. So you can see that we have welcome to React in Docker v2. So that's been deployed. And before, you know that it was saying default backend 404. That's before the ingress had been installed. So what I can actually do right now is I can run helm list and then run helm uninstall. No, sorry, helm delete falling penguin. Oh, my mistake. Helm delete falling penguin. And if I run kubectl, I'll get pod. If I'm quick enough, okay, nope. Yeah, that was too slow. So if I refresh this, you see that it's gone, which is something that is pretty cool about Helm. It's pretty fast to clean up. So let's go ahead and install again. But this time, actually no, this time nothing. I'm going to install again, same thing, but we have a different installation. It's called prodding grasshopper. And if I refresh, there we go. Great. So I'm going to go ahead and check out what's happening in our pods. So we have a pod here, and this is the pod that's actually responsible for this application. I'm gonna go ahead and start watching for the pods, and let's try and see what happens as we modify releases. Cool. So I have this this build script which allows me to tag whatever build I'm making. So I'm gonna make quick little changes to the application, create new images, like different versions, and then I'm gonna try to do the whole upgrade, rollback, etc., etc. So the first thing that I'm gonna do is we started off at a V3. Oh, sorry, a V2. I'm gonna go ahead and go to V3, and then immediately we want to go ahead and build a new tag called V3. And that's going to be a little bit faster because Docker caching is going to work to our advantage. So we have a V3 here. Remember the first one was V2. So yeah. And then I'm also gonna make a V4. So each one of these builds is using a different version of app.js. So we should expect like V4 to have V4 and V3 to have V3. So let's just wait for that to finish. Great. And then now if we head over to Docker images and we grep for pet store, you can see that there's latest V3 and V4. Great. So let's see some magical stuff happen. So if we run Helm list, you can see that we have an installation called prodding grasshopper, and currently it's on revision 1. And once again, if I refresh here, you can see that like this works. But let's try and upgrade that. So I've created a little script that deals with upgrading. And what that looks like is you have to run Helm upgrade. I'm running it in debug mode so that I guess we can see more information. So the release that we're dealing with is called prodding grasshopper. And the chart that we're using in order to deploy this is called pet store. Well, it's in the directory pet store. And actually, that should just be like that. And now what I'm going to do is I'm going to change the image tag and then set it to, forget what we're working on. So V3. So right now we're on V2. Let's go to V3. And what this will do is this is actually going to create a new revision of this particular installation. And that's because this this value has actually made it so that there is a diff between the manifest generated before and after. And Helm sees that as I guess, a change of state, and we'll go about essentially making sure that that happens. So you can see that what's happening now, if we have a look over here, is a new container is being created. And then once that container is created, and only then does our old container actually get terminated. And once again, if we head over to this URL and we refresh, you see we now have V3. And I think that's pretty cool. So let's run Helm list and see what's going on. So you can see that now we have 2 revisions of our application. So let's try and do this yet again and see the third one. So let's use V4 for the next deployment. So it's going to upgrade, same thing. If we go ahead and watch over here, you can see that it's creating a new container. And this was the container for V3, but you can see it's now being terminated because we're doing kind of like a rolling update type thing. And if I go back to the browser and I refresh, you can see we're now on V4. For you to be able to do this with like ordinary Kubernetes deployments, I don't know how long it would have taken for me to do that the traditional way, and I don't really want to go through the process of replicating that. So that's the first step, that like Helm allows you to essentially package your application into different versions and very easily allows you to manage deploying it, because I didn't have to like figure out or like piecewise deploy each one of the resources responsible for writing my application. I just gave Helm the chart, and Helm just made sure that it happens. And this is all the chart is, a bunch of templates. And then Helm also has, I guess, the added value of allowing me to have revisions. And it's not as simple as just saying revision 1, 2, 3, etc. There are a lot more bells and whistles to Helm that unfortunately I can't cover in this, but maybe in the next one. Oh, so let's see a really cool feature of Helm that allows you to move back and forth between different versions. And it's called rollback. So how rollback works is Helm is actually storing the manifest for every single one of your installation revisions. So you can go back and forth between them. And I think this is incredible because the speed with which I can go from V1 to V5 and back is, yeah, it's pretty cool. So what that looks like is Helm rollback. So if you recall, version 2 was actually, I think, version 3, and version 1 was latest, and version 3 was version 4. So I'm gonna just hop back and forth between those. So to be clear, Helm upgrade, if there is actually like a completely different manifest generated, will generate a new installation, but Helm rollback allows you to move between installations. Sorry, not a new installation, like a new version of an installation. That's what Helm upgrade does. So Helm upgrade will generate a new version of an installation. So you can see, well, a new revision. Sorry, I should stop using the term version. And Helm rollback allows you to jump or like to move back and forth between revisions. And I've been talking, but I need to show that now. So Helm rollback, what does it need? It needs 2 arguments: the release name and the revision number. So Helm rollback prodding grass hopper. Let's go back to revision 2. Oh, happy helming. Rollback was a success. So you can see there's some changes happening here. And what do we expect? So right now we're in the latest version, which has V4, but we've moved, I think we only moved 1 back. So we expect V3 to be showing now. So if I refresh V3, and if I roll back to version 3, like clockwork, it's already like moving back to the latest version. So rolling back and forth, very easy. So I'm already in V4. And then suddenly, if I decided that these latest versions weren't really doing it for me, I can go all the way to version 1. And once again, that just happens like clockwork. The container is creating, etc., etc. And well, I gotta wait for that to finish. It's terminating. That was mid change. And of course, you'd get like a gateway timeout. But yeah, if I refresh now, I get V2. So you can see that with Helm, it's very easy for you to go back and forth between the different versions of your package. And the cool thing is, while all this is happening, I can then come along and say, well, hold on. I have this installation running here, but I actually want to have a completely, like, I want a completely different installation that's on a different version. So at the moment, we're on V2, right? I can go ahead and run an installation of this chart. And I want V4, but I also want it to be the case that, and I have to be careful about this one. So what I want is I want to use a completely different host for this. So I'm going to do ingress. And then I would like to call it v4.local. Also, ingress.host, the first entry is equal to blah, 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 blah. And I'm going to do a dry run so that, I'm happy with it. So you can see v4 local, everything's working. And then I'm going to get rid of the dry run. Oh, so that should all work. And I'm going to try to go to this, but obviously it's not going to work because my Etsy host isn't set up to handle this. But what I can do is sudo and head over to Etsy host. And let me just go ahead and cool. So let's go ahead and save that. And then now if I refresh this, you can see that I'm on v4 on one version of my application and I'm on v2 on the other one. And if I run Helm list, you can see that I have 2 different installations of my application running, and I didn't need to manage like a whole bunch of manifests because Helm allows me to kind of like abstract all that away. So Helm is very cool. So actually, the way that I got into Helm was through GitLab, and I'd like to do a different session on GitLab because I don't think I've quite looked at like CI/CD the same way ever since I started playing around with GitLab. So like setting up Jenkins and like whatever else on your own is a pretty tall order. Like there's a lot of work involved, but GitLab just seems to make things so easy and the user experience is incredible. So one of the cool things about, I guess, GitLab is they have this thing called Auto DevOps. And I got to play around with Auto DevOps a little bit, I guess a week or so ago. And a significant part of Auto DevOps is when you actually create review apps or you deploy to staging production or whatever. And all that is done using Helm. So you can basically provision a Kubernetes cluster on your cloud platform, I don't know, AWS, Google, Kubernetes engine, and point GitLab to that Kubernetes cluster. And GitLab can just like seamlessly start building your application and pushing it into Kubernetes and even give you a URL. Like the whole concept of review apps for me was just like, whoa, there's a lot of work that you need to put in order to actually make that work. I think I first saw that as an integration on Heroku, and I was like, the team must have done like a ton of work in order to make that work. But it seems like it's that much more accessible now that we have tools like Helm, because Helm kind of abstracts all the management of like manifests, and basically allows you to manage your packages, version them, run them concurrently, etc., etc. Yeah, and I think I'm gonna stop things there for today. I think I covered like quite a few things. I'll probably do another one of these in the next week. This was the first one, so it might not have had as much direction as it could have, but I just want to get in the habit of doing these. I think it helps me kind of like solidify the things that I'm learning, and also it's a great way for me to share information with people outside. I should probably check to see if there was any activity. Let's see. Well, I don't know. In any case, it's been fun. I'm gonna go ahead and close this off. And yeah, if there's any interest in any particular technology, it would be great if people just reached out, like message me or whatever. But yeah, next week maybe I'll do GitLab a little bit, because GitLab actually creates the charts for you automatically. But what I'd like to move towards is creating my own charts, because maybe my application has different requirements to those provided by GitLab. So yeah, I hope that was useful. Thank you.